Hello everyone. We want to introduce you a smart map application based on outdoor navigation and reverse image search. Have you ever been in a scenario that at your first time to school, you want to know how to get to a specific building, so you open the digital map on your mobile phone, but a huge gray section is tagged as the school with no more detailed information. Therefore, you have to take a photo of the school map with view for direction. Or have you been in another scenario that you see a photo like the first one, and you have an idea in your mind that this place is nice, I must go there during my next trip. But the problem is that you have no idea about what that building is. Therefore, we designed a smart map application that can solve all these problems with two techniques: photo map outdoor navigation and reverse image search. In this presentation, we will firstly give you a general idea about what can be done with this application. Then we will explain the two techniques applied to this application. A detailed introduction of the app design will be given after that. Now let me introduce you the functions that our application has. The first one is the normal navigation function based on start and destination location, which I think you are all familiar with. The second one is the outdoor navigation function based on photo map, which enables users to use a detailed photo map to navigate in conjunction with your current location. The third one is the image search function that allows users to search for destination address based on photos. The last function is an exciting one that allows users who search for the same place to join a chat room to exchange information. But how exactly these functions can be achieved? My teammates will explain the core techniques used before introducing our design.
The photo map is an application designed by Jonas and his team in 2009. It is designed to support spontaneous interaction with "You Are Here" maps in the environment without the need of downloading map data on the mobile devices. This application can support users because you will often see such specialized maps on public signs, suited where they may be required on the go. This is an interface of a map applications where you are going to navigate the Melbourne Uni campus. The red icon here indicates the current location. This image is familiar to be shown at every entrance of the university campus, and also the red icon indicates you are here. As you can see in these two maps, the left is from a map application. There is no detailed information to be shown on the map. On the right is the image taken by your phone. You can see here is very detailed locations of each building, but the problem is that you cannot navigate from this image. So the program here is to mapping the image into the mobile map application so you can navigate directly on your phone. The first step of approaching the image is to transparent it. After you move the image into the map application, you can see the size of the image is not suitable to be presented in the map. So you need to scale and rotate the image. After scaling and rotation, you can mapping the image into the map application very accurately. After all these processes, while you open the map application again, you can use this generated map as a navigation guide.
The reverse image search is a technique which based on the content-based image retrieval query to search information. Look at these two pictures. We can easily know they are same place by our eyes, but how the computer to know they are same place, and how the computer to get some information through comparing two pictures. In addition, these two pictures have different sizes. There are two algorithms used in the reverse image search technology. The first algorithm is scalar invariant feature transform (SIFT). Another algorithm is maximally stable extreme regions (MSER). Next, I will introduce these two algorithms briefly. The process of SIFT can divide as 4 steps. The first step, it needs to extract feature objects from images. Secondly, compare each feature object between the origin image and the object image. Thirdly, filter good matches from key points. The key points can be the feature objects about scale, orientation, and location. Finally, calculate the probability of some particular feature sets which represent the presets of the object based on given fitting position and the possible number of face matches. If the probability of some particular feature sets of two images satisfy the given fitting precision and the possible number of false matches, we can determine the two pictures are similarly. MSER is to binarize a grayscale image. Grayscale value from 0 to 255, and the threshold is incremented from 0 to 255. This formula is the mathematical definition of MSER, where the PQI means a connected region when the threshold is I. Delta is a small amount of change in the grayscale threshold. Small qi is the rate of change of the region PQI when the threshold is I. When small qi is a local minimum, then PQI is the maximal stable extreme region. So we can use this formula to check whether two images are similar or not. Next, our team member will introduce the design of our app.
After understanding these techniques, now I will explain the application design. As you see, we developed two sets of server and database for the system that each is designed to achieve part of the functions. The first part is responsible for navigation. Spatial data is stored in the database. When outdoor navigation function is selected, mobile device sends a required message to server. Then the server will query the database for map information and send back to the mobile device. Then users can adjust the photo to match the map. The photo will then be georeferenced by applying the outdoor navigation technique. The second part of the system is responsible for image search and chat room function. Database in this part holds different kinds of features of landmark pictures. When a user uploads a landmark image for searching, server uses the algorithms that have been explained before to analyze the image. Server then uses features of this image to form a query that requires the database to return satisfactory images and geolocations. The results are presented as a list to users, and users can choose in which order they want to view. If the picture does not exist in the database, the picture will be written in the database with the address that users choose in the list. Each location in the database is linked to a chat room. The first person who searches this address can send a requirement to build a chat room for communicating with others. We hope our design can provide a more convenient service to users. That's all for our presentation. Thank you for listening.